Hi, I'm Sandi Genovese, and I want to talk to you about the Pythagorean theorem tile set. If you look here, you can see that these are actually foam tiles, and I'm going to pull one of them out. This one is the right triangle, and of course you'll talk to your students about the theorem where if they know the length of side A and side B, they can figure out the length of side C. In fact, if they know the length of any of two sides of a right triangle, they can figure out always the length of the third side. The formula is a squared, so the square of side A is represented with this foam tile, plus b squared. So here is the foam tile that represents b squared, which is the square created with this side, and it needs to equal the square of side C. Okay, that's great. And if your kids want to really put these on top and see that this plus this equals this, it's difficult to tell that that works. You know, short of trying to cut things up and maneuver all these pieces, it's just difficult to know, does this and this really equal this? This is where this foam frame comes in so handy, because the two sides of the frame are identical. The right triangles are identical. This right triangle perfectly matches all the rest. So when you place the foam triangles into the frame, and then you go back and you add in a squared, and here you add in b squared, you can see that a squared and b squared plus these four triangles fit that frame perfectly. By just configuring the triangles within the frame in this fashion, it allows you then to go back and slide in the foam tile for c squared, and it perfectly fits. So that if you then subtract out the four triangles, you are left with a squared plus b squared does in fact equal c squared. You know, with this manipulative, instead of your students memorizing a formula, they're going to actually understand it.